Good morning, class. We are looking at Calculus 1, Exam 2 review, covering Chapter 3, Differentiation Rules, from 3.1 to 3.8. Here's Part 3, covering 3.4 and 3.5. 3.4, the chain rule. 3.5, implicit differentiation. All right, so y equals sine squared of 8x, and we are differentiating. Again, reminding you of some of the formulas, such as the power rule, exponential rule, um, sinusoidal functions, product rule, quotient rule, extended power rule, which is part of the uh, chain rule. So sine squared of 8x, I'm going to rewrite it as sine of 8x to the power of 2, so it becomes clear that you really, in essence, are dealing with the extended power rule. So if I want to differentiate this, g of x to the power of, and g of x is sine of 8x. So think of this as g of x. So we need n, which is 2. Then we need the g to the power of n minus 1. So sine 8x to the power of 1, or simply sine 8x. And finally, we need g prime. So we need to differentiate sine of 8x, this last part. So what is the derivative of sine? It's cosine 8x. And then because 8x itself is a function of x, by the chain rule times 8. Rewrite this as 16 sine 8x cosine 8x. Now, part B, f of x is 3x times 3 to the power of x, and we are looking at the product rule. So I know this is f, but let's call this fg. And so you need f prime. F prime is just 3 times g, which is 3 to the power of x, plus g prime which is an exponential function. An exponential function is always itself, so 3 to the power of x. Is the base e? No, so you need ln 3. This is by the logarithmic properties. Since the exponent is x, you're done with that. And now g prime f times 3x. In other words, this is f prime g. This is g prime f, and you're done as far as calculus is concerned. Now we are going to go with our algebraic techniques to simplify this. To do so, notice this 3 has exponent 1, and they add up using the product rule of exponential. So 3 to the power of 1 plus x, or x plus 1, makes no difference. Let me just erase everything and it becomes clear what I'm. So this one has exponent 1. So this becomes 3 to the power of x plus 1. This one and this one, because this has exponent 1 also, they become the same thing, 3 to the power of x plus 1, and the rest of them remain. Clearly, 3 to the power of x plus 1 is in common. So if you take this out, that gives you 1. This gives you ln 3 times x. And ln 3 times x, we put the x in front because If you write it in this format, you have to write ln3, then the raised dot, then x. We don't want anybody to be under the assumption this is ln of 3x, which is not true. So you put the x in front to be on the safe side. Observations show that the length L in millimeters from nose to tail of a Siberian tiger can be estimated by the function L equals 0.25 W to the power of 2.6, where W is the weight of the tiger in kilograms. Furthermore, a young tiger's weight can be estimated in terms of its age t in days by the function W equals 3 plus 0.21 t. How long is the tiger when it's 100 days old? There are two ways to do that, and I'm going to look at both ways. One way is just the weights given. So if you put 100 into this formula, because t is 100 days, it gives you the weight. Of course, 0.21 times 100 is 21. Remember, two decimals, two zeros cancel each other. We have 24 kilograms. Now that we have the weight, length is a function of weight. So replace the W with 24, and that gives you the length. So 0.25 times 24 to the power of 2.6, you put this into a calculator, raise it to the power of 2.6, and then times 0.25, and it gives you 969.369 millimeters. As far as the number of decimals, you always pay attention to what they ask you. This is close to 1,000 millimeters, okay? And reminding you that 1 meter is 100 centimeters. And 1 centimeter is 10 millimeters. Okay, so it's close to 1 meter, just to give you an idea. Also 1 meter or 3 feet if you having said that, this is elementary algebra. And again, that's one way to do it. We will look at the second method in a moment, but the second part is asking for calculus. At what rate? That means differentiation. Is the length increasing when it is 100 days old? So at what rate? So we are talking about dLdt. At what rate is the length increasing when it's 100 days old, dLdt. So let me write it in this format. And I want to go to the Leibniz's notation. dy dt is dy du dt. So look at dLdt here. So what is the intermediate variable from L to T? Is W. That's why you put dW. So that is the intermediate variable. To go from L to T, the intermediate variable is W. Now, what is dLdW? Let's look at this one. This is a basic power rule. So it's 0.25 times 2.6 times W to the power of 2.6 minus 1, which is 1.6. So that's dLdW. Times dW dt, dW dt. What is the derivative of this with respect to t? Just 0.21. So you multiply the three numbers, 0.25, 2.6, and 0.21. You put it in front. And when it's 100 days old, the tiger, the weight, we know it to be 24. We've already calculated. So replace it. Otherwise, replace the W with the formula and replace the T with 100. We don't have to do that because we already have the answer 24. And put it into a calculator, results in 22.0532 millimeters per day. dLdt, units of the length over the units of the time. Okay, How many decimals? Whatever they ask you, you follow that accordingly. Now, this is fine, and we're done. This case is simple enough that we can find the composite function. That means L is a function of W, make it a function of T by replacing the W with 3 plus 0.21T. So here's the second method, find the composite function. So we use this method, and again, if it's hard to find the composite function, you must go with this method. In this case, it's easy to do it, and I want to show you both methods. So if I replace the T, part A, T with 100, I should get the same answer here. So 0.25 times 3 plus 0.21 times 100 to the power of 2.6, and you will get to the same answer. So it's very straightforward. Again, as I mentioned, close to almost 1 meter, because 1,000 becomes 1 meter. What about L prime? Now, if I differentiate this with respect to time, I get 0.25 times 2.6 times the same thing to the power of 1.6 times the derivative of the inside, which is 0.21. One more time, 0.25, 2.6 sits in front, this is N. In other words, we are using the extended power rule, okay? So 0.25 doesn't go away. N is 2.6. G of x to the power of n minus 1, the parentheses to the power of 2.6 minus 1, which makes it 1.6. G prime, the derivative of the inside is 0.21. If you multiply those numbers, you get this one. And notice, these two are identical. If you change the W to 3 plus 0.21T, you get exactly what we have here. And if you plug in 100 now, and you get the same answer here. What is the point? Either method is just as easy, and you are familiar with both methods. Use the one that works the best for you. Okay, that's the idea. The amount of glass recycled in a community is G of P equals square root of 0.5 P squared plus 7 tons, where P is the population in thousands. It is estimated that 2 years from now, the population of a community will be P of T equals 4.4 plus 0.1 T squared thousands. How many tons of glass are expected to be recycled 4 years from now? Similar to the previous question, we have two functions, and we can go by the composite function or just the weights given. Generally speaking, in a case like that, composite function makes it more difficult. So basically, replace the T with 4 here, and that gives you the P, the population in thousands. So 4 squared is 16 times 0.1 is 1.6, and 4.4 is 6, and 6 means 6,000 people, because this is in thousands. So number 6, or whatever number, times 1,000. Now, if you plug this one into here, replace the P with number 6. This is 36.5 times 36. Half of it is 18. 18 and 7, 25. Square root of 25 is 5. 5 tons, same units, tons of glass. Find the rate at which the amount of glass recycled is changing with respect to time 4 years from now. Even if they don't mention that, you have to put the units always, any application. So what do they mean by that? They mean dg/dt. So the amount of glass, rate means differentiation, glass dg with respect to time dt. So Again, using Leibniz's notation, dy dt is dy du, du dt. So what takes you from y to t is du, the intermediate variable. What takes us from g to t? The intermediate variable is p. So we're going to write this dg and dt, and what goes in here is whatever is in between the two variables, p. So we put dp. So we find this one, we find this one, we multiply the two, then we plug it. So how do we find them? It's very simple. First and foremost, to find dgdp, that means differentiate this with respect to p, p becomes the independent variable, you write it to the power of 1/2. So how do we differentiate this? Extended power rule. N is 1/2. G of x to the power of n minus 1, this thing to the power of 1/2 minus 1, which makes it negative 1/2, times g prime. What is the derivative of the inside? 0.5 times 2p, which is p. So this thing is dgdp. This thing is dgdp. What is dp dt? Now go to the second function, p of t. And if I want to differentiate that, this is 0.1 times 2, 0.2 t. So this is dp dt. And according to part A, p is 6, t here is 4. Okay, so t is 4 for here, p is 6 for there. Remember, when t was 4, p was calculated. So we are going to plug it. Before we plug in, let's simplify the whole thing. So 1 is at top, p is at top, 0.2 t is at top. So 1 times p times 0.2 times t. This one, if you take it down, takes the square root, becomes a positive 1/2 and takes the square root format. So you take this down, positive 1/2 next to 2, next to 2, positive 1/2, and it becomes a square root. So one more time, 1 times p times 0.2 t, that's the numerator. 1 times 0.2 is 0.2 pt. This is 2 square root of 0.5 p squared plus 5. Same p as we mentioned, t equals to 4. We are going to replace things, which means we're going to replace the p, we're going to replace the t. Now, I hope you realize this part, we already did that. Remember the 5 we came up with, so that works out to be the same 5 here. Okay. So 0.2 times 6 times 4 over 2 times 5. The denominator is 10, the numerator is 4.8, so you create one more decimal, 0.48. And units of g over units of t, tons of glass per year. So which means 4 years from now, the amount of glass recycled is increasing at a rate of 0.48 tons of glass per year. By the way, positive means increasing. If it were negative, that means decreasing. Now, the second method, and I'm not going to do that, is actually a little bit more complicated. Replace the p with this one. So the second method is to find g as a function of t, the composite function. So 0.5 remains. P is changed to 4.4 plus 0.1 t squared to the power of 3 plus 7. So you have to work on this. It's not a bad idea for practice. Okay, class? Implicit differentiation. Functions expressed by one variable are defined explicitly in terms of another variable. Example, y equals x squared minus 2x plus 1, or in general, y equals f of x. Some functions are defined implicitly by a relation between x and y, such as x squared plus y squared equals 25, or x cubed plus y cubed equals 6x4. In some cases, it is possible to solve such an equation for y, and in some cases, it is not easy or even impossible to do so. In such cases, we can use the method of implicit differentiation. This consists of differentiating both sides of the equation with respect to x and then solving the resulting equation for y prime or dy dx. Let's start with a very simple example to do it both ways because they're doable both ways. 4x plus 2y equals 10. We're going to do it explicitly and we're going to do it implicitly. Explicitly, simply put, you have to solve for y. So 4x plus 2y, I'm going to move the 4x, becomes negative 4x on the right. Divide everything by 2. Y equals negative 2x plus 5. And clearly y prime or dy dx is negative 2, and you're done. So that's the format we had seen before. There is not much to it. The second one, implicitly, we start with this, and we are going to differentiate both sides with respect to x. So everybody knows for x, the derivative with respect to x is 4. But what about 2y? Remember, y is like g of x. So d dx of y, you say y prime or dy dx. Okay, y is the same as g of x. Literally replace it with g of x if it helps. So 4x is 4 plus 2y to either y prime or dy dx. 10, any number, results in 0. And so you move the 4, negative 4, you divide by 2, you get the same thing. On purpose, I wrote this as y prime, this one as dy dx. I want to mention those are different notations giving us the same thing. So either way, so you can use any notation. The advantage of this is that it is also telling you what is the independent variable. Over here, you may not know y is a function of t or x or theta or something else. Given the circle x squared plus y squared equals 25, we want to find y prime, and I'm going to go with the implicit differentiation. You can practice solving for y and trying it that way. And so, having said that, we are going to differentiate this both sides implicitly with respect to x. And to do so, I want to remind you that if you're differentiating g to the power g of x to the power of n, becomes n g of x is the power of n minus 1 g prime of x. But instead of g of x, if we have y, the derivative becomes very similar. N, instead of g of x, we're going to write y to the power of n minus 1. Instead of g prime, we're going to write y prime or dy dx. So this is 2x. According to this, 2y, y prime, any number results in 0. Now you could write 2y dy dx. It's the same thing. Move the 2x, make it negative on the other side. Divide by 2y and simplify. Becomes negative x over y. We're done. Second part, find an equation of a tangent line at the point 3, 4. And so to come up with the equation of a tangent line, you need two things. You need a pair, which is given, and you need the slope. To find the slope, since we have the derivative, plug in this case, we have to plug in x as well as y. And so Here's the pair, x is 3, y is 4, plug in, and we get negative 3/4. Needless to say, this is a circle centered at 0, 0 with the radius square root of 25, which is 5. So y minus y1 equals m times x minus x of 1. Y minus 4 equals m negative 3/4 x minus 3. Distribute and add 4. 4 is 16 over 4 with 9 becomes 25. So 25 over 4. Y equals negative 3/4 x plus 25 over 4. If you plug in 3, it works, which means this process, not this one. This process is right. So implicit differentiation. Find dy dx equals y prime. So sometimes we use dy dx, sometimes we use y prime in the case where x is the independent variable. One may be easier to write. So we are going to differentiate this with respect to x. We start with x cubed, we get 3x squared. Y cubed, again, I remind you, the derivative of y is y prime or dy dx. But if it's y to the power of n is n, y to the power of n minus 1, y prime. Therefore, for this one, we're going to say 3y squared dy dx or y prime. Please understand, y prime or dy dx. So it's the extended power rule. Instead of g of x, we have y. What about the right side? Immediately, we recognize this as the product of 6x and y. We put a raised dot in between. We treat this as a product rule. And the answer is f prime g plus g prime f. So the derivative of 6x is 6 times y. And the derivative of y is just y prime, or since we use dy dx times 6x. And this is it. You're done with calculus. We are going to use a couple of steps of algebraic method to simplify. So to do so, what are we solving for? We are solving for dy dx or y prime, which means we are going to move things around. So how do we move this? This one has dy dx. We move it to the left side, becomes negative. This one, we move it to the right side, becomes negative. We are interested in taking dy dx out. So we factor dy dx. And we notice there's a common factor of 3 on both sides. We take out also the 3. So you don't have to move things. Just get rid of the common factor of 3 from both sides. And now all you have to do, put this parentheses under this parentheses. So dy dx or y prime is 2y minus x squared, the right side, over the coefficient of dy dx, y squared minus 2x, and we are done. Use implicit differentiation to find dy dx of y prime. 2x plus y to the power of 4 is x minus 2y. And we are going to differentiate starting with the left side. So we have the extended power rule. So something to the power of 4. First and foremost, we need 4 and then 2x plus y cubed. Then we need the derivative of the inside. 2x gives you 2, y gives you y prime times the parentheses 2 plus y prime. we move to the right side. This is 1 minus 2 y prime. Again, most of the time it's easier to write y prime for the sake of, solving an equation, but it really makes no difference. They both mean the same thing. So having said that, this is the only calculus step. Now we are going to do a bunch of steps to get to y prime. Everything is algebra, and that's the point. The calculus part is not huge. And so let's do that. If I multiply this by 2, I get 8 times 2x plus y cubed. And then this thing times y prime. So please understand, I'm going to distribute 2 and then y prime. So 2 times this becomes 8, y prime. I write the same thing times y prime. The right side I'm not touching. What are we solving for? Y prime. If I'm solving for y prime, I need to move this to the right, becomes negative. I need to move this to the right, becomes positive. So what happens? This negative 2y prime becomes positive 2y prime. 8 times 2x plus y quantity cubed goes to the other side, becomes negative. We are solving for y prime. On the left side, we have to take the y prime out as a common factor. So if I take the y prime out, I'm left with this plus this on the left side. And I'm not doing anything to the right. So one more time. You take the y prime out, you have this piece plus 2. So if you divide the right side by this bracket, you're done. The only thing I want to make a point of. So the y dx of y prime is the right side, 1 minus 8 times 2x plus y quantity cube over the brackets, 4 times 2x plus y quantity cube plus 2. The only thing I want to mention, as you see, the denominator has a factor of 2. If the numerator has a factor of 2, also you have to simplify. It doesn't. We continue with implicit differentiation where sine y plus 2x cubed y squared equal to 6, and we differentiate piece by piece. Sine, we know the derivative of sine is cosine, and if it's sine of g of x, is cosine of g of x, g prime of x. So this becomes cosine y, y prime or dy dx. What about this one? It's a product of 2x cubed and y squared. We put a raised dot in between. So we know that it's the product rule that we need to use. So f is 2x cubed, g is y squared. So f prime g plus g prime f. 2x cubed, the derivative is 6x squared, then times y squared, right? This is f prime g. Plus g prime, the derivative of y squared, 2y y prime or 2y dy dx. That's g prime now f times a 2x cubed. The right side is a number, 0. So just for this part, we have f prime g plus g prime f. Okay. And again, I put asterisk. We're done. With what? Calculus. So you want to solve for dy dx, bring everything involving dy dx together, and otherwise just Quickly, this is 6x squared y squared. This is 4x cubed y. So you just rewrite it, makes it easier to see. And as you can see, everything remains except this guy moves to the right and becomes negative. Then this 2, we can take the dy dx out. If I take the dy dx out, this gives me cosine y, this gives me 4x cubed y. So on the left side, factor out the dy dx and move this one, make it negative on the other side. So what is dy dx? The right side divided by the parentheses. So dy dx is the right side, negative 6x squared y squared, over the parentheses cosine y plus 4x cubed y. Find an equation of a tangent line for x times e to the power of y plus y e to the power of x equals 1 at 0, 1. So we need two things. We need a pair, x comma y is given. We need the slope, and that means differentiation. So we are going to differentiate accordingly. And so what we are looking at is the product of these two pieces using the product rule, and then these two pieces, the product rule. Okay, so let's start with the first one. This one is 1 times e to the power of y plus e to the power of y. The derivative is always itself, any exponential. However, is the exponent x? No, it's a function of x, so y prime or dy dx. And now times f times x. So that's the first piece, this one. Now let's move to this one. Again, fg. The derivative of y is y prime times g, which is e to the power of x, plus g prime f. The derivative of e to the power of x is itself, times f, which is y, and then the right side, because it's a number, becomes here. And again, you're done. Right here, if you plug in 0, 1, that means replace the x with 0, y, and y with 1, it will give you y prime, and it becomes the slope. I want you to know that. Becomes the slope if you plug in. But I want to solve for y prime. To do so, we're going to put everything involving y prime together, and everything else moves. In other words, this one goes to the right side, becomes negative. So it's e to the power of y negative. And this is e to the power of x times y negative. Both of them are negative on the right side. These two, I'm going to take out y prime. And if I do so, when I take the y prime out, I get e to the power of y times x plus e to the power of x. And the other two pieces are negative on the other side. So I'm going to take both of them inside the parentheses, put a negative. And so y prime is the right side over the parentheses. Okay, so this 2, when we did the differentiation, divide by the parentheses. So y prime is negative, and I have a different color to emphasize the negative sign remains. E to the power of y plus e to the power of x over y, divided by e to the power of yx plus e to the power of x. Now, what is the slope? Replace the x with 0 and y with 1. So m is y prime such that you use 0, 1. So replace the x with 0, y with 1. In other words, this is your calculus step. Everything else is algebra, everybody. So negative remains. What is e to the power of 1? e. What is e to the power of 0? 1. So this is e plus 1. Doesn't matter what this is, times 0 becomes 0, e to the power of 0 is 1. And this is the exact answer. And so what do you do to get rid of the fraction? You make everything negative in the numerator. And now, because this is the y-intercept, which means b equals 1, we are going to use y equals mx plus b, which means this thing times x plus b, which is 1, and that's an exact answer. Now, you can distribute it or not, but this is the exact answer, and you want to keep it that way. Want to find dy dx for the equation where the x dt is 10, x is 4, y equals negative 2. Now, the very first thing I want you to notice is this. The moment you see dy dt or dx dt or both means what? T is the independent variable, which means the derivative of x is no longer x. What is it? Dx dt. So that's the key for here. Normally in the application of related rates, t is the independent variable. So I want to start with that. So 4x is no longer just 4. When you differentiate that, you get 4 dx dt. Now this is just like before, right? 3 times 4, 12 y cubed. Instead of dy dx, we're going to say dy dt. So this is easy. X squared is not just 2x. It's 2x dx dt. Now, since we are interested in finding dy dt, the value of that, really there are two ways. Just plug in, and I'm going to show you that one. That means 4 times 10, 12 times negative 2 cubed, dy dt missing in action, 2 times x is 4, dx dt is 10. This is 40. This is minus 8 times 12 is minus 96. The right side is 80. And so obviously you subtract 40, you get 40, and divide. And you get 40 over negative 96. Both of them are divisible by 8, negative 5 over 12. And that is the final answer. However, just to remind you how you could solve for dy dt and then plug in, because they may ask you to solve for dy dt. I want to go over the algebra behind that. Since I want to solve for dy dt, I'm going to move this guy. Here's the second method, everybody. And I'm going to divide both sides by 12y cubed. And when I do that, I notice the numerator has a factor of 2. So I take out the 2, and this would be dy dt as dx dt times x minus 2 over 6y cubed. Now, if I plug in, I get exactly the same thing. Okay, just in case. Find dx dt for the equation of 3x plus y e to the power of x equals 20, where dy dt is given, x is given, y is given. Again, the moment you see dx dt, t is the independent variable. And so the first piece gives you 3 dx dt. And the second piece, we put a raised dot in between, and we treat it as a product rule, fg. So f prime is y prime. That's what I mean instead of y prime. Use dy dt because t is the independent variable. You don't want to mix it up. If you use y prime is okay, as long as you remember t is the independent variable. So dy dt times e to the power of x plus, now e to the power of x, the derivative is itself, and times dx dt. So e to the power of x dx dt times y. So in other words, and of course, any number gives you 0. In other words, what you're looking at here, this is f prime g, this is g prime f. And again, you can plug in. Let's plug in and I will show you when we solve that. And this is it. This is the only calculus step, everybody. You're done with calculus. So let's plug in. Let's plug in. So 3 dx dt plus dy dt is negative 8. E to the power of x is 0 plus e to the power of x is 0. Dx dt times minus 1 equals. And so you have, this one is 3, this is 1, this is, so you get minus 8 minus dx dt, and these two, they add up to 2 dx dt. Move the 8, divide by 2, you get 4, and you're done. Now, the second method is to actually solve for dx dt, which means over here, this piece moves to the right, becomes negative. Everything else remains. You're solving for dx dt, so keep that and factor it. So you get 3 plus y e to the power of x. Divide the right side by the parentheses 3 plus y e to the power of x, and that's dx dt. If you plug in now, you get exactly the same thing as last time, as I mentioned. So you can practice that. Again, the moment I see dy dt, t is the independent variable. That means the derivative of x is no longer 1. And so we want to find this and evaluate it. So let's work on this. Using the extended power rule, we have a 4 times the same thing cubed, 5x plus y cubed. Now, dy dx, the derivative of the inside. This is 5 dx dt, this is dy dt. So believe it or not, this is the derivative of this piece. Minus x becomes minus dx dt. Any number results in 0. Again, let me put asterisk. This is important to notice. You're done, everybody. With what? Calculus. Algebra, plug in. This time I'm going to just plug in. The point being, there's a lot of algebraic steps, but not a lot of calculus steps. So we plug in those numbers, meaning 4 times 5. X is replaced with 2 plus y. That means plus negative 9 cubed. This is 5 dx dt, 3 dy dt missing, minus dx dt equal to 0. So this is a 10 minus 9 is 1, 1 cubed is 1. And 5 times 3 is 15. So if I distribute the 4, I get 60 plus 4 dy dt. 60 and negative 3, they add up to 57. 57 moves to the other side, becomes negative. Divide by 4. Dy dt is negative 57 over 4. And I highly recommend for practice, you guys solve this for dy dt and then plug in, just for practice. But if they want just the value, this is one way to do. y equals 1 over 7x squared minus x to the power of 4. We want to differentiate that back to the chain rule. We are going to bring this up and make it -4 using negative exponential rules everybody is familiar with, and getting it ready for the extended power. Y prime is -4 times the same thing to the power of -5, because -4 minus 1 is -5, times the derivative of the parentheses 14x minus 1. And notice this piece goes down and takes a positive exponent 5. This one and this one remain up. So y prime is -4 times 14x minus 1 over 7x squared minus x to the power of +5. H of x is cosine of 5t over 5t. We want to differentiate this. So f over g. We are going to use the quotient rule. So we have h prime of x, a big fraction bar, f prime, the derivative of the top, we're going to work on it. So we start with cosine becomes negative sine of the same thing, 5t, and then times 5 by the chain rule. So that's the derivative of the top. That's f prime. What about g? Times g times 5t minus g prime minus 5 times f cosine of 5t over g squared, 5t squared. So you square that, 25t squared. Done with calculus. We are going to simplify this. And again, reminding you, this is f prime g minus g prime f. If you want, I can write it underneath. F prime g minus g prime. And so the numerator has a common factor of -5. So if I take the negative out and the 5 out, I get -5. I have sine 5t, okay, times 5t. I put the 5t in front. This guy goes away and it becomes just plus cosine 5t. So one more time, just take the -5 out. So you have this piece and this piece, you put the 5t in front. You have only this piece, and again, negative changes to positive because you took out the -5. Now this 5 cancel out this one, changing it to 5. The negative sign remains, and I keep the negative sign in front of a fraction bar. Or put this in a parenthesis, put a negative in front of it, or minus this, minus that. So minus in front of a fraction bar, 5t, sine of 5t. Cosine 5t over 5t squared. So again, pay attention where you can put this accordingly.